you guys have all worked and dealt with Pythagorean theorem. We all know what it looks like. We all know that in a Pythagorean theorem, what kind of triangle does it have to work with? A right triangle. Okay. We all know that the Pythagorean theorem always works with right triangles. It can only work with right triangles. In right triangles, you guys have to remember that there are specific parts. The one part that we look at, obviously, is going to be the right angle. It's kind of convenient because you kind of have to have that in order to have the right triangle. Do you guys remember what the part was that was across from the right angle? Hypotenuse. Good. Does it ever move? No. One of the things that is definite, that never changes, is that the side opposite the right angle is always, 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 always the hypotenuse.
I got an 11 last night, mister.
All right. The other two parts are always called legs. They're interchangeable. It does not matter which one is which. They're just called legs. All right. So this is a leg, and this is a leg. Now, we all know Pythagorean theorem. What was that? Do you remember? Okay. Which one is always the C value? The longest part is the hypotenuse. Okay. The hypotenuse is always going to be your C value. The other two are interchangeable. They can go either spot. It does not matter. Okay. So Pythagorean theorem tells us a squared plus b squared equals c squared. Okay. And as you guys are aware of, this is stuff that we've been doing. Oh, geez, we did this with distance formula back in chapter 1. Remember how we talked about distance formula? We had distance between two ordered pairs. You had that huge, long, drawn-out equation that you would use for it. And I told you, just figure out how far apart the x's are, how far apart the y's are. Use the Pythagorean theorem, that's kind of the same thing. Right? That's where all distance formula comes from. So, yeah, you guys, this is one of those things that you've been using for a long time. It's kind of funny that in geometry it takes up till middle of January to actually get to the point of defining it officially. But yeah, so like I said, this is stuff that you guys have all seen. This is stuff that you guys have all done. This isn't going to be any too crazy. What happens with this now is that we're going to solve for specific pieces. And we'll just kind of use one. Mute that right snap. What's going to happen here is we're going to start solving for specific parts. And that's where I want us to understand that it is so important to label. I know that Pythagorean theorem stuff is really easy to work with, but the sooner we get in the habit of labeling our parts, it's going to make our lives so much easier for next week when we get to the trig stuff. Okay? So what I want to do here is, first of all, we'll draw our little triangle. We've got two sides, we're missing a side leg. And I'm going to ask you guys the question pretty regularly. Do we know the hypotenuse? Yes, okay. So what I want to do is label it. There's my hypotenuse, because it is always, always, always across from the right angle. Right? The other two are interchangeable. They're just the legs, A's and B's. It doesn't matter which one you call it. So 15 is going to play the role of C, 9 will call it A, and X will call it B. Are we all right with that? So really all this winds up being is 9 squared plus something squared is 15 squared. Okay. Now, this is where the multi-view is worth every penny. What we're going to be doing is we're going to be leaving our answers in what are called simplified radical form. What that means is that if the answer is the square root of 12, decimals don't exist. The answer would be 2 root 3. Okay, things like that. These calculators do that for you. It is imperative that you guys get one ASAP. So mathing this is pretty easy. Pressing some buttons, you get 81 x squared and a 225 if I'm not mistaken. Subtract things over, still using your calculator. What is that then? 144, thank you. I lost track where I was at. And then the square root of that. Remember, how do you undo squaring? Square root.
Yes, yeah.
I thought you said square.
I mean, I did, but I'm not the square root.
X would be 12, right? Technically, when you take a square root over an equal sign, what should you do to your answer? You guys remember that from algebra? It would be plus minus. Remember that? Remember what squaring means. Squaring means you're multiplying the same value, the same value by itself twice. So if you think about it, negative 2 times negative 2 is positive 4. 2 times 2 is positive 4. But can we have a side length that's negative 12? No. So we disregard that. Also, just a little FYI, when you're undoing roots, when you're undoing that, to undo that, last year in algebra, did you guys ever work with exponent rules? Like how do you say things, you add exponents, or you multiply and all that? I think you guys might have seen, if you had this, x squared times x to the 5th, do you guys remember what you did? What did you do? You add them together, good. So you got x to the 7th. Do you remember what you did if it was x cubed to the 5th? Yeah, excellent. So you got x to the 15th. Now here's what's crazy. Do you know what that is? Do you know what it is as an exponent? This is the same thing as x to the 1/2. So if you have x squared and you have to undo it, remember how you said you multiply, power to power, you multiply? What's 1/2 times 2? 1. That's why this works. This is nothing you have to worry about for this class, but you'll see this a lot next year. All right, this is a lot of stuff you'll see next year when we get it, and you guys get down for 2. It's one of the first, one of the first sections that we talk about in second semester. Just a little, so don't freak out if you realize, wait, square root is a half power? What do you think a cube root would be then? You're right, 1/3. Okay, and that's how stuff works.
Yeah,
all right.
I remember. I hated that.
Don't worry about it. You don't need to know any of this right now. I'm just showing you why these things kind of work themselves through.
Oh no.
Hey.
I remember.
Because if you think about it, going back to the Pythagorean theorem, when you go back to the right triangle, what angle is the biggest in a right triangle? The right angle, which means what side length has to be the longest? The hypotenuse across the right angle. So the C value is always the longest side. Okay. Let's try another one. Sure, you can move them anywhere you want. No big deal. It's like this. Isn't this still 17 and that's still 8? Is the hypotenuse still the hypotenuse? Is the leg still a leg? Yeah. So what are you solving for, a leg or a hypotenuse in this case? A leg, okay. So are you okay in saying that 17 is C? So we would say x squared plus 8 squared is 17 squared? Is that okay?
Yeah.
Would it be the same if I turned it sideways? Yeah. Doesn't matter. Okay. Once again, as you get going into most of these things, you guys should be able to do a lot of it rather easily. Because I know you've done this. X squared equals, if you go into the calculator and you just type in, oh, I don't have a calculator open, sorry.
I still can't believe it, man. I can't believe it. You gotta see.
What's that?
You gotta come see me work. It's so crazy, man.
I'm sure. But I promise we'll get out there. So again, if I take, in this one here, do you guys agree that the x squared, if I just move my values over, I'm going to get 17 squared, subtract 8 squared, just by moving numbers? Are we okay with that? So, all I'm doing is if I take 17 squared, subtract 8 squared, hit enter, I get 225. This is where these calculators work out rather nicely. Instead of retyping in things, you can do second square root of your answer. Okay? Square root button is, oh, it's next to 7.
That equals 15.
Yep.
Oh, I see.
You
Okay.
still gonna give me calculator?
Yeah, I got. If you want to borrow one for right now, it's fine. Yeah, I got plenty for myself. I got plenty of them. They're $15. We got plenty of them, so don't worry. Yes, sir. Yep, that's all it says. It is ridiculously simple. Okay, let's look at an example that isn't a clean number then. Skip ahead here. I don't want to get to those. Oh. For example, perfect. Flip it. You said it 164 minus the other way. I knew you would do it right, but just be careful how you say it. Everybody okay with this one? Like Christian was saying, that 12 is playing the role of a hypotenuse again? So if we write it out, we can say x squared plus 8 squared is 12 squared. All right? I know that 8 squared is just some number, so if I write it out, x squared is going to equal 12 squared subtract 8 squared. And like Christian was just saying, 12 squared was the 144, 8 squared is the 64. So we go to our calculator. Bless you. Bless you. And you get 80. Now, here's where it's important, besides looking at our phones. Put it away. It's got the earbuds in, you can't hear me. Go ahead, Kim. Again, take the square root of your answer. Second root of your answer. It gives you what's called simplified radical form. Notice there is no decimal. And that's how your answer should look. There are no decimals in these things. Your answer is 4 root 5. Well, if you had to do it without a calculator, you'd have to take the square root of 80. And then you'd have to figure out, well, what are the perfect squares that are hiding in it? And you know that that's going to be 16 times 5. And that's where you get the 4 root 5. Okay. So the idea here is you gotta make sure you have, gentlemen, cut it out. You gotta make sure you have the multi-view calculator because it does all of it for you. Okay. Go back to this. If you had, what was it? It was 144. I'm sorry, 12 squared minus 8 squared. Hit enter. Okay. Second square root of your answer. The answer button is the negative button. But you have to get second though. All right? And it goes from there. That answer key, learning to use that now is going to save your butts next week. Tremendously. Okay? You got to understand how to use that answer key. That way you don't have to worry about trying to rewrite certain values down. It just gets really, really, really messy if you don't use it. Okay? Yeah. Now, the other thing that'll happen sometimes with the triangles is that within them, you might get a side length that looks like this. Okay? So in this case here, I'm trying to figure out what my hypotenuse is. All right? Now, this is where you have to be extremely cautious. What's different now with this leg is that there's a square root in it, okay? Which means when you write this down, you have to put parentheses around it. All right? Anytime that you've got a root, you've got to put parentheses around it, otherwise it will not work correctly when you type it to the calculator. So when I go to the calculator, I now have it written down the way I should type it in. That's the important thing when we're looking at stuff like this. Move this over a second. Room. Now So here, I would type in my calculator, parentheses, 2 square root 3. Now, look what happens when you're with your cursor. See how the cursor is staying underneath the radical right now? Correct. Very good, very good. You got to press the side button to get out from underneath it. Now you have to close the parentheses. Then you square it. That's how that should look. It should look on the screen identically to what you have written here. Okay? That's the way this stuff's supposed to go. And then I put in plus 4 squared, and now I can hit enter.
So is that like your real answer?
That is x squared.
Okay.
So, what's that? Next to the 7. Okay. So now I know that 28 is x squared, which means now what do I do to solve for x? Square root it. So now I go back and do the same idea. Second square root of my answer, 2 root 7.
Should be 7, so you can tell them the final score. So we get back. We done figured out, so we would be like 4.
And that's where it goes, the idea. If you know your perfect squares, 4, 9, 16, 25, you can go into the what's underneath the radical. I think that's called the radical. Yeah. Whatever that number is underneath the root, and if you can factor, like you're saying, if you can factor that out by pulling out 4s, pulling out 9s, 16s, things like that, you're doing it in your head, which is cool. But if you've got a button, you got a button. Now here's the hang up on this stuff. I know not everybody has the multi-view calculators when they're doing their work. Could you get to this point right here without having to solve stuff, at least write it all out, and then when you get into class real quick, press a bunch of buttons and be done with it? Yeah, it's gonna be okay. Until everybody gets one of these calculators, but this is how this stuff's gonna work, all right? So, not terrible?
That's really easy.
I see what you did there. Okay. Now, oops, wrong one. Does anything change if I write it this way? No. What did I do? I just flipped it, right? Okay. So, this means it's a right triangle, correct? If that's a true statement, it's a right triangle, like 3 squared plus 4 squared equals, well, what's 3 squared? 9, 4 squared? 9 and 16 is how much? What's the square root of that? 5. So what happens is we're checking to see we verified it was a true statement. Now, here's what you can do also. Sometimes you might be asked to classify the triangle, whether it's going to be acute, obtuse, or right. We know if it's a right triangle, Pythagorean theorem holds true because it has to hold true because no other triangles make that work with. The other two are just acute or obtuse. Now, take a guess if the C value is smaller, C squared is smaller than A squared plus B squared, or C squared is bigger than A squared and B squared. Which one of those do you think is acute? Which one do you think is obtuse? Correct. And that's why I put it this way. Obtuse angles are bigger, aren't they? Obtuse angles are bigger. Acute angles are smaller. So if the C squared value is smaller, it's acute. If it's bigger, it's obtuse. That's why I write it with the C values on the left-hand side. Textbooks usually put it the other way around. Because you think of it in your head, oh, it's little. It's little. So it's smaller. So it's acute. Okay? It's bigger. It's obtuse. So what'll happen is you're going to get 3 values. 8, 13, and 4. Which one of those numbers has to play the role of C? Why? Because it's the biggest. Okay? They'll jumble up the numbers on you and move them around and make you try to figure out which one goes where. Obviously, it's pretty easy. It's got to be 13 because it's the biggest number. So what we do is this. We write it as, well, is 13 squared, put the little box in, and then we put 4 squared plus 8 squared. Go to your calculator. Type in what's 13 squared, hit enter. Move this up. 169. 4 squared is 16, 8 squared is 64, and last I checked, 16 plus 64 is smaller than 169, isn't it? That's 80, right? So that's bigger. What kind of a triangle is it? There you go.
And now all you have to do is just add them and add that side 3 and that's it.
Remember, there's the 3 of them are if the c squared equals a squared plus b squared, it's right triangle. If c squared is smaller than the 2, it's a cube. If it's bigger, it's obtuse. It's all two. So that's the other thing that's kind of nice with Pythagorean theorem is that you can mix up some of these things and use it to distinguish what kind of triangles you have without drawing. Okay. The weird stuff will come into play with this. Let me open this one up real quick. The weird stuff will come like this. It's going to give you 3 dimensions. It might give you a triangle, it might not. You can't assume what value goes where. But I don't know if the square root of 22 is bigger or smaller than 14. Okay, you know what I mean? Do you know how to get a decimal equivalent just to get the idea of what that is? Do you know how to do that on the calculator? Okay. What do you mean by click simplify? So if I do square root of 22 and I hit enter, this calculator just spits out square root of 22. Do you remember what button you pressed to get the decimal? Do you guys? I know some of you guys probably remember. The double arrow. Yep. You hit the double arrow, and it'll give you a decimal equivalent. Is the square root of 22 bigger or smaller than 14? It's smaller. So that means in this example, 14 is playing the role of the C side. Okay? And then we do that.
Now this is complex. When I'm reading that, I got share. What happened?
What do you mean?
Like why did you just choose?
Is 14 bigger than 13?
Oh, okay.
Remember, the biggest value is always going to go for the C. Okay? It's the biggest number. Yeah, we're just looking at the biggest number. Okay. Don't always, and that's the downfall sometimes when you look at diagrams. Not all diagrams can be drawn to scale. They're just going to put it together, and you might get caught by angle side siding something. Assuming. Okay. As you go through that. Now, go ahead.
So for the 22 side, it's saying that side is
Square root. So it's just some crummy decimal.
Right. Yeah. Okay. I just wanted to.
Yeah, and that's what they do. They throw stuff.
That 22 is the side is saying.
No, the square root of 22 is.
Yeah.
So when I go to check this in my calculator, again, we're still pressing the same kind of buttons here. We just do 14 squared, hit enter. We get 196. When I type in the square root of 22 and I have to square it, remember, parentheses, square root 22, right arrow, close them, square. And then I also can put in plus 13 squared and hit enter. And it gives me 191. What kind of a triangle is it? What is it? Good, very good. It's obtuse. Since this is bigger, it's obtuse. The trickiest part of this stuff, guys, is to remember to put parentheses around your roots. If you remember that, you're gonna be okay. Also, remembering how to get decimal equivalencies. Okay, that's the other big thing of this. Right? What's that? Yeah. Let me go back here. It was root 22, 13, and 14. Okay. Let's look at it all real quick.
I'm so tired.
What do you have?
It's a right angle.
Yeah.
Then do you use that long side as the C no matter what?
Yes.
But
If it gives it to you, yes.
But if there's none, then
You have to do the figure it out. Okay. So in this one here, again, they're kind of showing you. It's kind of leaning you towards 15 having to be the C. But what do we have to double check to make sure it is in fact? Yeah. So I have to go to my calculator real quick and just make sure that this isn't bigger than this, just in case. So again, in the calculator, oops. Just put this on this side. I do 4 square root 11. It gives me that again, which is fine. Then you're right, 13.27. Always go 2 decimals. I want to get you in the habit of 2 decimals, okay? Obviously, that is smaller than 15. I hope you guys agree. All right, it's a tough one to agree on. So that means that we're checking 15 squared. What's the relationship with it between?
do you use the biggest number as X? Or
C? Yeah, it has to be. Because remember, if this is going to be a right angle, can you get any other angles in a triangle that are bigger than a right angle? No, which means the largest side length has to be across from it. That's where all that, remember we're doing all this stuff? That's where all this stuff comes back to play. And then we check it with plus. Now when I do that 4 root 11, I got to put that in parentheses. Okay? It goes back to using the calculator. So let's see here, 7 squared plus quantity 4 root 11, right arrow, parentheses, square. I get 225.
That's 50.
Correct, which means what kind of a triangle is it?
you know, a right angle.
Equilateral? Could go out and live and say nope. It's a right triangle. It's gotta be a right triangle. If it was equilateral, would all the sides be the same?
Because
All right, so since they're equal, that has to be a right triangle. What was it? Yeah. Since these two, oh, I see what you're saying because the numbers are equal to each other. That's why you thought that. Okay. No, this means that they have to be a right triangle. Yep. Because the c squared equals the a squared and b squared. Yep. Okay. And that's what this looks like. Remember, the trickiest part of this stuff, guys, is to make sure that you use parentheses around your root stuff when you're typing them in. Otherwise, they're going to get messed up. Let's see. I'm pretty sure you'll get this done.
I believe you could have that.
But I bet you free custody.
No problem. So again, you guys have examples of just about everything we just did. It shouldn't come as any surprise for any of these types of problems. There's 12 of them, and you got a good 12, 15 minutes, so I'm pretty sure you get the bulk of this stuff before you walk in. Okay? Can't see this stuff. It's flare. I'm fine, thank you.
I find
So, does that have to do all of them? Yes, please. 12 of them. I think you can hack it. Jeez.
Actually, not that bad.
No, I know they're not that bad. That's why I told you. This is the perfect stuff for a Friday.
So, I have a question.
What's that?
So, for this one right here, this would be B, right? Because it has the.
Whoa, knucklehead.
Oh, wait, I'm turning it.
Yeah. Yeah, slow. You're just gonna mistake. Okay. What's the hypotenuse? Okay. There you go. Start using that. Oh, you remember you have to square all of it. So don't forget this chunk has to be squared as well. You just use Pythagorean theorem solve for that last side. And remember, guys, you're just using Pythagorean theorem on this stuff. This should be, kind of easy. Yeah, you'll get weird values if you're not careful with the parentheses. That's why I want to make sure you guys keep seeing that. Whoa.
Put it on the other side.
No, you're moving it. How do you move a positive? Okay. Yep, it's just all you're doing is solving an equation, working backwards, solving an equation. The order how you solve it never changes. Even though it's got some root stuff to it, it shouldn't be